So number 11 then from the 2022 mechanics paper, you've got here, it's a differential equation, it's a first order differential equation, it's a linear first order differential equation. Linear because y just appears on its own, just to the first power, no squares or square roots and so on. Given these conditions, when x is 1, so you have to find the particular solution then, when x is 1, y is 3 upon 2 e squared. Well, I'll just rewrite that as dy by dx and then explicitly see what that is. So I've just got y in its own here is x e to the 2x. Well, the way you do this is you multiply all of the terms to turn the left-hand side here into an exact derivative. It'll be the pattern for the product rule you've got. It's almost there, because when you've got a product, then you differentiate one, leave the other alone, and then do it the other way around. So there's y on its own, and there's y differentiated. So this should be the x function on its own, but I don't know what it is. And this is part of the answer, but that part's enough to give you a clue as to what that function should have been, because that will be the derivative or the inner derivative of this function. So what we do there is, to find what this multiplying factor is, and this multiplying factor will be that expression in x, you do e, that's the same one you have with the other differential one. The handy thing about e is it just keeps regurgitating itself, popping out the derivative of the inner part, popping this out. E to the integral of whatever this says, but it's a negative watch. Don't just put 1 over x. Negative 1 upon x dx. Now, knowing to do that is the first mark, getting the integrating factor. So that would be e, that negative would come out. That's e to the negative ln x. I could pop that negative inside, make that e to the ln 1 upon x. Yes, of course, there's a plus c, but by the rules of indices, a plus c would just be a multiplication by e to the c, which is a constant, and there's no point multiplying everything by a constant just to divide it out again. And that's quite handy, because that just comes to 1 upon x, because you've got the inverses there. So that's worth a mark for actually getting that integrating factor. Maybe should have moved that further over, so I may have to move this further over this way then. So now you multiply by it. Now, sometimes you don't show that explicitly, but I will show it explicitly here. So what I've got is, I've got 1 over x dy by dx minus 1 over x squared y equals, and very handy that knocks out that x, because that would have been a bit of a pest to try and integrate. I'll put it in anyway. 1 over x times x e to the 2x. That's the sage. You just multiply everything by it. So this side, this is exactly what you would get if you were to differentiate 1 over x times y. There's 1 over x, there's its derivative, negative 1 over x squared. There's y, there's its derivative. So if you were to integrate this up, that would pop back to 1 upon x times y. And that cancels out nicely just to leave an e to the 2x to be integrated. Now, that gets a mark. Now integrate it, so I'll just leave that just now. 1 upon x times y equals, and e's nice because it just stays e to the 2x, but divide by that inner derivative, but plus c. That's where this is going to come in. In fact, I think that gets a mark. Now we need to work out this plus c. So I think I'll do that over here. So using the initial conditions, when x is 1, y is 3 upon 2 e squared. So when x is 1, that'll just be 1 over 1 times 3 upon 2 e squared equals a half of e to the 2 plus c. So that says you've got c is equal to, well, there's 3 halves of e squared, but I'll be taking away 1 half, so that's 2 halves, so it'll just be a whole e squared. That's worth a mark. Now you just pop it into this. 1 upon xy equals a half e to the 2x plus e squared. Take that x across and multiply, and you're there. Y equals a half x e to the 2x plus x e squared. Either way around you like. I'd have been tempted to say there's a common factor of x in there. So I might have gone on and said, and I might have taken that half out at the same time. So I might have said I've got a half x times, that'll just be e to the 2x plus 2e squared. I'll just leave it like this. That's the one they wanted. So in that form, the e squared should really go in front of the x because the convention is you put the coefficient in front of the variable.